6.4 is on similarity in right triangles. And we're going to talk about a very specific right triangle. If you have a right triangle and an altitude that is on the side that is the hypotenuse, it will split, that altitude will split the triangle into three similar triangles. The little triangle, the middle triangle, and the big triangle are all similar to each other. Now for me, it is quite difficult for me to just visually see what sides are proportional to what. So what I like to do is I like to either draw arrows or write out certain things. So here's what I'm going to suggest to you. If you're working on problems that deal with this, I would recommend that you look at the smallest triangle, and then I would, whatever my smallest triangle is, I would draw an arrow inside the smallest triangle going from the shortest to the middle side like that. And if you draw an arrow like that inside the triangle in your smallest triangle, you'll know that the letters for this smallest triangle go small, middle, large, A, D, C. Something like that. And then I'm going to do the same thing except for the middle triangle. I'm going to go from the smallest side of the middle triangle to the largest, and so in order it would be C, D, B. If I look at these arrows, one arrow goes from the bottom to the top, the other arrow goes from the top to the bottom. And so I have to know that this skinny piece here matches up with that skinny piece there when I'm setting up my proportion. This is something that kind of turns, if you will. And the last triangle that is proportional to is the shortest to the longest, looks like this, and it goes A, C, B for that very last triangle. The whole reason that I have you write that out is so that you know what is proportional to what. That lets you know in the red triangle you have this short side compares to the, let's say, the middle side. Let's do short, middle. And in my red triangle, the short in the middle is AD over DC. In my middle triangle, the short is DC compares to DB. And then in my large triangle, the short is AC, and the middle is CB. That was supposed to be in green. I didn't quite get that to be in green, so I'm going to try that one more time. Green and green. Hopefully that looks a little bit better. And that's just the shortest side compared to the middle, and these are all proportions you could use to solve any of the problems down below. So anyways, the whole reason I bring this up is because we're going to have to solve a lot of problems dealing with these proportions, and it's hard to know what matches up. And I'm showing you an example that has the smallest triangle on the left. Some of your homework questions will have the smallest triangle on the right. If it is on the right, then everything's arrows will be slightly backwards. Let me show you what I mean. Let's say the smallest triangle's on the right-hand side this time. Then your arrows would be like this. Upwards, downwards, over, and around, just so you know what matches up with what. So when you're setting up your problems, make sure you know what's the shortest, what's the middle, what's the longest, because that's how you're going to solve and figure out what's X and what's Y in a lot of the problems. Let's do some examples. These are examples in your textbook. I have 3 picked out for you. Numbers 5, 9, and 31. Let's do number 5 together. Number 5 says solve for x and solve for y. I'm going to use two different triangles here to set up a proportion. My first triangle I'm going to use is I'm going to put this one here in blue. I'm going to use that middle triangle. And I want you to think of, I don't know what y is, but I do know what this one, this is the middle side of the middle triangle, and then I have the longest side of this middle triangle called the hypotenuse. So I'm going to use middle and the longest, just so that I know that that's what my proportion needs to be. It needs to be 9 over x. So I keep things lined up using the blue triangle for my first ratio. And then what I need to do is I need to look for another triangle that has the same information with the same variable if possible. So I look at it and I need a middle and a long. This little triangle is not going to help me because the middle is a y and the long it has nothing next to it. So instead I'm going to jump to the big triangle and I'm going to look for the middle of the big triangle is x, and the long side, the hypotenuse, would be 9 plus 3, which is 12. Setting it up is a lot of times the hardest part, which is why sometimes writing out middle and long will help you, or draw arrows to help you. And then you can use the cross products property. X times x is x squared. 9 times 12, I believe, is 108. You can double check me on that. And then I'll square root both sides. Technically, that's the same thing as the absolute value, which is why there are two possible answers for this. Make sure you always reduce square roots. That's why we had unit 1 and unit 0 to remind you how to reduce. You were taught a long time ago something like if you factor out a 2, and that's 54, 6 times 9, 3 times 3, 2 times 3. You're looking for pairs. A 3 can pop out, a 2 can pop out, which would be 6 root 3. Feel free to double check me on that. Technically, it's a positive or negative 6 root 3, but these are geometry distances. Because of that, we only need to focus on the positive distance, and we'll only write down that x is equal to 6 root 3. If you have trouble with this, don't forget, you can double check yourself with the calculator, because calculators do radical form for you, especially the models that I've recommended that you do use in the back of the classroom. That's how we found x. You could do the same thing by setting up proportions for y, or you could do it by using the Pythagorean theorem. It is up to you. If setting up proportions is hard for you, then use the Pythagorean theorem. The Pythagorean theorem is more work, though. So let's do another proportion, just so you can see how much less work it is. If I use short of the smallest triangle and middle, let's do short, middle, short, middle. The short side is 3, the middle side is y, and I'm using the smallest triangle, equals. Now I need something else where there's a short and a middle. Maybe it's these two, the blue triangle. The shortest is y, the middle is 9, y over 9. If I'm solving this proportion, y times y is y squared equals 3 times 9 is 27. Square roots, technically the absolute value. Simplifying, feel free to simplify that on your own. These are equal to positive and negative root 3s, 3 root 3s, I'm sorry. But we only care about positive distances, so y has to be equal to 3 root 3. Any questions? And then example number 2 is number 9. Number 9 says, use the figure to complete each proportion. They give you a bunch of letters. They say G over E is equal to E over what? If you feel like drawing the arrows, draw the arrows. It might help you to go G over E is equal to E over what? Or, if it helps you, write G is the short of the small triangle. E is the middle of the small triangle. That means I need to use the short and middle of the other triangle. E and then over H. That's the idea. I don't know why I chose that one. That seems too easy to do as an example together, but it'll give you an idea in case you get stuck on any of those other ones. And the last one, a perfect honors Math 2 level question, number 31. I love this question because the answer is not very apparent and you have to have a lot of algebra skills to do it. Number 31, find the value of x. Number 31 is a little bit harder to see. If you get stuck, like I can't tell, is this the small triangle or is this the small triangle? I can't quite tell. It almost looks the same, but I'm going to say that this is the short triangle. So I'm going to draw some arrows here. I'm going to go short to tall, tall to short, and then overall we'll go like this. Those arrows help me as I'm setting up proportions. Now I'm going to cover up this triangle over here. And by looking at just this triangle on the right, the smallest triangle that I think is there, this is the short side. Since this goes to the middle, this must be the longest side or the hypotenuse. I'm going to do short side over the longest side, and I'm going to call that x over x plus 2. I'm just using this, the short over the longest side of x plus 2. Now, if I go to the next triangle, I try the short and the longest, I don't have any information there and the other any information there. That's not going to help me to use this left triangle. So what I must need to use is the big triangle. The shortest of the big triangle is x plus 2. And the biggest of the big triangle, the hypotenuse, is 5 plus x. And so once you get to this step, you have now set it up correctly. It doesn't look very easy to solve because everything's an x and x plus 2, an x plus 2, and a 5 plus x. But you've done it right. Now we cross multiply. And this is going to bring back some of the stuff. 5 plus x and x plus 5 are the same thing. This is going to bring back some of the stuff that you did in Unit 1. And it's a great time for us to look at it again, considering our final is in 3 weeks. And you're going to have some Unit 1 stuff on the final. And we talked about how to multiply a monomial times a binomial and a binomial times itself. We talked about a FOIL method and so on. So I'm going to distribute x squared plus 5x. And I'm going to do this thing called FOILing, which is first, outside, inside, last. And when you do the outside is a 2x and the inside is a 2x, I'm going to put those together in my head and say it's 4x. The last is 2 times 2, which is a plus 4. Hopefully we remember that. And then I'm going to subtract x squared and subtract x squared from both sides. Let's just do that next. And we have 5x equals x squared minus x squared goes away. 4x plus 4. We can subtract 4x then. And what do you know? We have now answered the question. X is equal to 4. Any questions? I'm going to stop your notes right there then.